Okay, let's solve the question where we have like terms to deal with. Okay, so like terms are basically terms with the same variable raised to the same power. Okay, so in this case, x and 4x would be like terms. So they can have different coefficients, but they have to have the same variable or the same letter raised to the same power. Okay, so we have two like terms. Now, when you're solving equations with like terms, you're going to put them on one side of the equation for themselves, and you're going to put everything else on the opposite side of the equation. Okay, you don't have to move a particular like term. You can move any one of them to where the other is. But I'm just going to choose to bring this x to where 4x is. Okay, we would get, so x is no longer on this side. So we're going to end up with 7 is equal to 4x minus 5. So since this x was positive on this side, it's going to become minus x when we bring it over the equal sign. Similar to when you're moving your constant over the equal sign. Okay, we need to get our like terms on one side of the equation for themselves. So we're going to have to get rid of this 5 here. And the quickest way to do that is to just bring it over the equal sign and change the sign that is in front of it. Okay, so this is going to become 7 plus 5 on this side. And remember, the 5 is no longer on this side, so we're going to write what we have left, which is 4x minus x. Alright, now that we have our like terms on one side of the equation for themselves, we're going to go ahead and solve. Alright, so that's 12. Now, how do we combine like terms? We combine our like terms by either adding or subtracting their coefficients. But you notice that there's no coefficient in front of this x here. Whenever there's no coefficient in front of a variable, you can write a coefficient of 1. Okay, so we're going to write 1 for this x here. Then we're going to go ahead and subtract in this case. It depends on what operation is there. So if this were an addition sign, then we would have added 4 plus 1, the coefficients. Since we have subtract, we're going to subtract the coefficients to combine our like terms. Okay, so we're going to get 3x on this side. But remember, we need to solve this equation. So to solve the equation, we need to get our variable on one side of the equation by itself. And we have to get rid of the 3 to do that. So since 3 is a coefficient, we are going to divide both sides of the equation by the coefficient. Okay, so this cancels. This is going to give us 4, and we have x on this side. So since x is now on one side of the equation by itself, it is now solved. And our final answer is x is equal to 4. Alright, let's do question E. So in this case, we have an inequality because we have an inequality sign, not an equal sign. So how do we solve inequalities? The way you solve inequalities is practically, well, it's not the same, but it's very similar to how you solve your algebraic equations, with just 2 exceptions. Okay, the exceptions are when you swap sides with the terms in your inequality, you also have to change the direction of the inequality sign to point in the opposite direction. The other exception is that when you multiply or divide by a negative number, you are going to have to change the direction of the sign to the opposite direction as well. Okay, so we're not sure if we have any of that to deal with as yet. So we're just going to go ahead and solve just like how you would solve an algebraic equation. Okay, like I said, I recommend that you get rid of your constants first. So I'm going to get rid of this 3 by bringing it over to the other side of my inequality. And we're going to be left with negative 2x on this side. Remember, 3 is no longer on this side, so we're not going to rewrite that. On this side, we have 5 minus 3, and we know that's going to give us 2. Okay, so the next number we need to get rid of is this negative 2. And to do that, we're going to divide both sides by negative 2 since it is a coefficient. Okay, so this cancels. Then we have x. Okay, so here now we are dealing with a special case. So this is the exception. You notice that we are dividing, or we divided by a negative number, negative 2. That means I'm going to have to flip the sign. My inequality sign must be pointing in the opposite direction. Okay, so it's going to become less than or equal to negative 1. And this is our final answer. Okay, here we have expressions involving indices. Now, just go back to your laws of indices to see how do you deal with expressions where you have powers or indices. So indices is just another term for powers. Okay, you're also going to follow the order of operations rule. So we have multiplication or division. If these are the only 2 operations in your expression, you don't have to do one before the other. So I'm just going to randomly choose to multiply first. So how do we multiply 3 to the 7th power times 3 to the 2nd power? We're going to apply the law of indices for multiplication. And that law says when you're multiplying 2 numbers with the same base, the base is the larger number. So the base here would be 3. So it's 3 for this number, it is 3 for this number as well. Okay, so we have 2 numbers with the same base. The law of indices for multiplying says when you're multiplying 2 numbers with the same base, you keep the same base and add the powers. Okay, so this part of it is going to give us. So we're going to keep the same base, so that is why I wrote 3, but we're going to add the powers. So remember, this can only be done when the base is the same for both numbers. And that is going to give us 3 to the 9th power. Okay, but remember, we did not work out this part as yet. So we're going to have to include that here. So divide by 3. Okay, how do we deal with this now? There's no index or power for this number. Similar to when there's no coefficient for a variable, we can write a coefficient of 1. Same thing here. When there's no power for a number, you can write a power of 1. So I'm going to put a power of 1 here. Then we can go ahead and apply the law of indices for division. And that rule says when you are dividing numbers with the same base, you are going to subtract their powers and keep the same base. Okay, so we're going to keep the same base. The base is the same. It's 3. And we're going to subtract the powers. So we have 9 minus 1. And that is going to give us 3 to the 8th power. And this is our final answer. Alright, let's do question B. So the only operation here is multiplication. Sorry about that. Okay, the only operation here is multiplication. So we can just add up all of the powers at once. So they all have the same base. So we can apply the rule for the law rather for multiplying numbers with the same base. That means we're going to keep the base and add the powers. So that is going to be 1 plus 3 plus 5. And we're going to get our final answer, which is 2 to the 9th power. Okay, next one. For this question, this one is tricky. Now, you may have assumed that, or you may or may not have assumed that we can use one of the law of indices for this question. However, we can't. That is because we are adding these numbers. Now, there's no law of indices for addition. And another thing you should notice is that they don't have the same base. So the larger number is not the same. So one of them, the first one, the base is 3. The second one, the base is 2. So even if there was not addition there, even if there was multiplication or division, we cannot apply the law of indices here. So what you can do, you can probably just say 3 to the second power is 9 plus 2 to the third power would be 8. Also, the index or power tells you how many times you're going to multiply the number times itself. So 3 squared is 3 times 3. 3 to the third power, you're going to multiply 2 to the third power. You're going to multiply 2 times itself 3 times. And that is how I got 8. And you can probably just add them up and say 17. Okay, here's another example of where we cannot apply the law of indices. Well, there is just probably one law. This one is, you're not really calculating anything. It's just a rule of thumb. This one says any number raised to the power of 0 is equal to 1. So you could probably simplify this as 4 squared. That means you're going to multiply 4 times itself 2 times. So that's going to give you 16. Minus, okay, so 3 to the power of 0 is always equal to 1. So any number raised to the power of 0 is going to give you 1. So I'm going to put 1 here and we can just work out the rest to get 15. Alright, so let us do some questions involving different number-based systems. Which it is very similar to when you're doing operations involving numbers in different number-based systems. It is similar to when you're doing operations in base 10. Alright, let me explain. So let us do question A. Alright, when you're adding up your base 10 numbers, so remember the everyday number-based system that we use is base 10. What we do, we normally line up the digits according to their place values. So we line them up almost like in columns. You're going to do the same thing when you're adding in base 5. The difference is, as opposed to where we group tens in base 10, we group 5s in base 5. Let me explain. For example, let's say I'm going to add 2 regular base 10 numbers. Okay, so let us say we had 78 plus 24. We would start with the ones place. We would say 8 plus 4 is 12. We would write down the 2, carry the 1, and add up everything else in this column or this place value. So it's going to be 1 plus 7 is 8. 8 plus 2 is 10. And since there are no more place values to carry this 2, we're just going to write the 10 at the front of the number. We're going to be doing something similar when we are adding base 5 numbers. But the difference is, as opposed to carrying the 1 when we get a number that is 10 or more, we carry 1 when we get a number that is 10 or more. We're going to be carrying 1 when we get a number that is 5 or more, when we're adding in base 5. Alright, so 1 plus 4 is going to give you 5. Now keep in mind, for base 5, the only digits you're allowed to use are 0, 1, 2, 3, and 4. So we cannot write 5 in this place value or column. Instead, we're just going to carry 1 when we get a number that is 5 or more. Alright, so 1 plus 4 is going to give you 5. What I'm going to do, I am going to change that 5 to base 5. Now, what is 5 in base 5? All we have to do is find out how many groups of 5 can we get from 5, and we're going to put down the remainder, just like what we did up here. So we said there's 1 groups of 10, so we carried 1. Then we put down the remainder, which would be 2. So 1 groups of 10 from 12, remainder 2. Same thing that we're going to do here. So we have 1 group of 5 and remainder 0. So we're going to put down the 0 and carry 1 group of 5 to the next place value. Okay, so we continue. 1 plus 4 is 5. 5 plus 2 is 7. Remember, we can't write 7, so we're going to regroup at 5. Okay, so how many groups of 5 can we get from 7? That's going to be 1, remainder 2. So we're going to put down the 2 and carry that 1 group of 5 to the next place value. Alright, 1 plus 3 is 4, 4 plus 1 is 5. We can't write 5, so we already know how many groups of 5 and what remainder we're going to get. So we're just going to write down the remainder and carry the 1 to the next place value. Because there is 1 group of 5 from 5 with remainder 0, so we put down the 0, carry the 1 to the next place value. Okay, 1 plus 2 is 3, 3 plus 1 is 4, and 4 is allowed, so we're going to write down 4. So our final answer is going to be 4, 0, 2, 0, base 5. Okay, this part is very important as well. If you don't write the subscript 5, what we call subscript, if you don't write the subscript number to show what base it is in, someone might assume that you're talking about a base 10 number. So it's not 4020, it is 4020 base 5. So that is why the subscript 5 is very important to add to your final answer. Alright, let us go ahead and do question B. Okay, binary subtraction is very simple. So we don't really need to spend a lot of time on that. Okay, what we're going to do, Okay, so you're just going to line them up according to their place values, just like what you would do for regular subtraction. Alright, so we're going to take the first place value would be 0 minus 1. So since we can't do that, we're going to just take a 1 from this place value, and we're going to carry that to the place value where we want it to be. Okay, so what you're going to do, you're going to keep taking 1 until you get it to a place value where you want it to be, and that is going to give you